This video is going to show you how to multiply decimals using the algorithm method. Our example that we're going to use to do this is 4 2/10 times 56 hundredths. Notice how when I'm going to multiply these decimals, the decimal points don't have to be lined up like they do for if I were going to add them or subtract them. Okay, before we start multiplying these two decimals together, let's think about an estimate of what our product could be. So I know my first factor is around 4, and my second factor is around half. And if I took half of 4, it would be around 2. So I know that for my answer to make sense, it should be somewhere around the whole number 2. Now that I have an idea of what my answer should be like, let's talk about how we go about multiplying two decimals using the algorithm method. Okay, to start off, I want to multiply these two numbers pretending that those decimal points are not there. So instead of 4 2/10 times 56 hundredths, I'm going to multiply 42 times 56. The algorithm way, the way that I know how. So all I did was change both the decimal points and move them to make both of these numbers whole numbers. So 4.2 became 42, 0.56 or 56 hundredths became the whole number 56. So now I'm going to multiply these like normal. 6 times 2 is 12. 6 times 4 is 24, and one more is 25. Put my 0 and get rid of what I carried. 5 times 2 is 10. 5 times 4 is 20, plus one more is 21. I'm going to add these together. 2, 5, 3, and 2. So my answer for the second problem that I created, remember this was the original, and I turned them both into whole numbers, 42 and 56. The answer for this problem was 2,352. But let's talk about how we're going to figure out what the answer to our original problem was. In order to figure out what the answer for my original problem was, I'm going to have to count and see how many digits there are behind the decimal points in both these numbers. So for example, in the first factor, the digit 2 is behind the decimal point. In the second factor, there are 2 digits behind the decimal point. The 5 and the 6 are both behind that decimal point. So in total, there are 3 digits behind both the decimal points. So that means going back to my answer that I got for the whole number problem, because there were 3 digits behind the decimal points, I'm going to have to move the decimal point for this number 3 places. So originally it was there. I'm going to move it over 1, 2, 3, and create a new decimal point 3 places over. So that means that my answer to the original problem is 2 352 thousandths. So I'm going to write it below, and then we'll talk about why we can move the decimal places. Okay, so in our original problem, we changed 4 2/10 and made it 42. And if you think about it, all we really did when we did that was move that decimal over 1 to the right. We moved, in the second factor, we moved 56 hundredths and made it the whole number 56. And all we did when we did that was move that decimal to the right. If you notice, in our answer to the second problem, we did the opposite of that. We moved 1 to the left and then 2 more to the left. So we undid what we did before. And that's why you can move the same number of digits over to get your answer for the original problem. Now let's think about if our answer makes sense. We said we want our answer to be somewhere around 2, and 2 and 352 thousandths would be a good answer based on our estimate.